Hey all, in this session we are going to learn how to configure and verify some of the switch administration commands used to manage switching database templates, manage MAC address table, and troubleshoot the switch ports which will enter into error disable mode due to some of the other reason. Switching database manager. Before that, we're going to refresh something about content addressable memory, forwarding information base, and TCAM, that is ternary content addressable memory. To start with, multi-layer switches can be used for different tasks. We can use them for switching, routing, or a combination of both. Cisco switches uses content addressable memory for storing layer 2 information, that is MAC addresses, forwarding information base for storing layer 3 information, that is IP addresses, and TCAM, ternary content addressable memory, to store layer 2 and layer 3 informations for fast lookups. So what is content addressable memory? All Catalyst switch models use content addressable memory table for layer 2 switching. As the frame arrives on switch ports, the source MAC address are learned and recorded in the CAM table. The port of arrival and VLAN are both recorded in the table along with timestamp. If a MAC address learned on one port has moved to a different port, the MAC address and timestamp are recorded for the most recent arrival port. Then the previous entry will be deleted. If a MAC address is found already present in the table for the correct arrival port, only its timestamp is updated. Switches generally have large CAM tables so that many addresses can be looked up for frame forwarding. However, there is not enough space to hold every possible addresses on large networks. To manage the CAM table space, the stale entries, that is addresses that have not been heard from for a period of time, will be edged out. By default, idle CAM table entry are kept for 300 seconds before they are deleted. You can change the default settings using the following configuration command: MAC address table aging time, and you can specify the times in second. By default, MAC addresses are learned dynamically from incoming frames. So what is FIB? Forwarding information base table. Cisco uses FIB to make IP destination prefix based switching decisions. The FIB is conceptually similar to a routing table or information base. It maintains a mirror image of forwarding information contained in the IP routing table. When routing or topology changes occurs in the network, the IP routing table is updated, and these changes are reflected in the forwarding information base. The FIB maintains next hop address information based on the information in the IP routing table. So what is ternary content addressable memory, TCAM? The TCAM is an extension of CAM table concept. TCAM is commonly found in networking environment or networking equipment such as high performance routers and layer 3 switches to increase the speed of route lookup, packet classification, packet forwarding, and access control list based commands. The Cisco IOS constitutes of two components that are part of TCAM operations, namely Feature Manager and Switching Database Manager. The Feature Manager merges or compiles the access control entries in the TCAM table of Cisco Catalyst switch, whereas the Switching Database Manager comes handy in creating a partition of TCAM table on some of the Cisco Catalyst switches into areas of different functions. TCAM is usually used in router and layer 3 switches, as they will be having routing TCAM, while some layer 2 switches have TCAM for QoS and not for routing. So what is Switching Database Manager? Switching Database Manager is used on Cisco Catalyst switches to manage the memory usage or configure partition in the TCAM. So how a network administrator specifies size limits of memory partitions that different tables can occupy. It can be done using SDM templates that assigns values for each table. You can use SDM templates to configure system resources in the switch to optimize support for specific features depending on how the switch is used in the network. You can select a multiple template to provide maximum system usage for some functions or use the default template to balance resources. Versions of SDM templates. There are two versions. One is desktop template and another is aggregator template. So Catalyst 3750 switches supports only the desktop template, which is default template for desktop switches. When a Cisco Catalyst 3750 switch stack consists of 3750-12S and other models, only the desktop SDM template should be used. This is what Cisco recommends. Aggregator template. The default template for the Catalyst 3750-12S is the default aggregator template. The Catalyst 3750-12S switch can use the larger TCAM size available in the aggregator templates or can use the standard desktop templates as well. So Cisco recommends that the stack master is configured with an aggregator template if the stack consists of only Catalyst 3750-12S switches for quickly increasing the capacity of a network. The Catalyst 3750-12S alone supports both versions of SDM templates. So what is stacking? Some network switches have the ability to be connected to other switches and operate together as a single unit. These configurations are called stacks and are useful in expanding the switch network capacity without the hassle of managing multiple devices. Stackable switches can be added or removed from the stack as needed without affecting the overall performance of the stack. Depending on its topology, a stack can continue to transfer data even if a link or unit within the stack fails. This makes stacking an effective, flexible, and scalable solution to expand network capacity. To allocate ternary content addressable memory resources for different usages, the switch SDM template prioritizes system resources to optimize support for certain features. You can select one of the following SDM templates to optimize these features. Routing. The routing template maximizes system resources for IPv4 unicast routing, typically required for a router or aggregator in the center of a network. Maximizes system resources for the best unicast routing performance. Use this when you are using the switch as a router or route aggregator in the middle of the network. VLANs. The VLAN template disables routing and supports the maximum number of unicast MAC address. It would typically be selected for a layer 2 switch. Unicast routing will be automatically disabled, allowing the maximum number of supported MAC addresses if you choose the VLAN SDM template. The VLAN template would be used when the switch is being used as a purely layer 2 device. Choosing the VLAN template will actually disable routing. That is, number of entry for unicast or multicast route is absolutely zero. Default. The default template gives balance to all functions, that is, balance resources on all of the tables. Default template is a mix between routing and VLAN templates. This template gives a good balance between layer 2 and layer 3 capabilities. Access. The access template maximizes system resources for access control lists to accommodate a large number of ACLs. If you have configured your switch with larger number of ACLs, this template can be used. The switch also supports multiple dual IPv4 and IP version 6 templates for environments with both types of traffic. Using the dual stack template results in less TCAM capacity allowed for each resources. Do not use them if you plan to forward only IPv4 traffic. This table shows the resources allowed by each template for desktop or aggregator switches. The following SDM templates support IPv4 and IPv6 environments. You can go through this. And This is the resource. These are all the resources allowed by dual IPv4 IPv6 templates. So SDM commands. We're going to do some hands-on lab practicals on this at the end of the slide. How do you determine what template, that is desktop or aggregate template, the switch is using to partition memory and the amount of memory assigned to each table? By giving show SDM prefer in privilege execution mode. How to configure or set the SDM template? You can give the command SDM prefer and you can choose one of the following options, that is access, default, dual IPv4 and IPv6 in global configuration mode. And one thing you should keep in mind that when you select and configure new SDM template, you must reload the switch for configuration to take effect. After the system reboots, you can give the command show SDM prefer in privilege execute mode to verify the new template. If you enter the SDM prefer command before the switch is reloaded, the older template will be in effect. So if you give show SDM prefer in privilege execution mode, these are all the resources allotted by default in desktop routing template. How to configure a switch with routing template, a desktop routing template for a desktop switch or aggregating routing template for a Catalyst switch, a Catalyst 3750-12S switch. You can give SDM prefer routing and reload. How to configure the desktop routing template on Catalyst 3750-12S switch. SDM prefer routing desktop. How to configure IPv4 and IPv6 template, default template on desktop switch. Do not forget to reload the switch, otherwise the older template will be in effect. To return to the default template, use the no SDM prefer command followed by the running SDM template and reload the switch. Okay, it's time to get our hands dirty on switching database manager. First we will take a layer 2 switch. Go to privilege execution mode and show SDM prefer. You can see the default template, the current template is default template and the resources allotted: IPv4 MAC QS SES 128 and number of IPv4 MAC security SES 384. Now if you want to change it to some other template, the only other template available is QoS, because some layer 2 Cisco switches has TCAM for QoS and not for routing. See, one is default and another is QoS. Okay, let's change it to QoS. So let's check whether new template has come into effect or not. Do show SDM prefer. No, it's still the old template, default, because you need to reload the switch if at all the new template has to take the effect. We are reloading it. Go to privilege mode, show SDM prefer. Now the new template, QoS template, is in effect. So number of IPv4 MAC QoS is 384 and number of IPv4 MAC security ACS is 128. So if you give no SDM prefer QoS, it will go back to the default desktop template. Reload it. Now the switch is reloaded and now we can check. See, now the default template is in effect. In this session, we are going to learn how to configure and verify aggregator SDM templates using a layer 3 switch. I have selected 3560 multi-layer switch. You can see now we will go to privilege mode and give the command show SDM prefer. The default template will be desktop default. Now we will try to assign IP version 4 and IP version 6 addresses on switch interfaces. Unrecognized command. Why is that so? Because you cannot allot IP addresses directly to a switch port unless you give the command no switch port, as this command puts that interface in layer 3 mode known as routed port and makes it operate more like a router interface rather than a switch port. The IP address command assigns an IP version 4 address and network mask to the interface. However, it does not support VLAN subinterfaces, as only routers can have subinterfaces. It does not support layer 2 protocols as well, such as DTP and STP. If you give show running configuration, you can see the IP addresses assigned to fast Ethernet 0/1. Now we will try to assign IP version 6 address to an interface, no switch port. It will not take unrecognized command. Why is that so? Because the template is default, which does not support IP version 6. If you want to change the template as you would like to allot IP version 6 to an interface of the switch, then the templates needs to be changed. So let's change the template to dual IPv4 and IPv6 template routing. SDM prefer dual IPv4 and IP version 6 ? Default routing and VLAN. We will select routing. Let's check. We need to reload the switch in order to take that new template. Show SDM prefer. You can see its default IP version 4 and IP version 6 routing template has come into effect. Now configure terminal. Interface fast Ethernet 0/2. No switch port and IP version 6 address. This is IP version 6. Enter. No shutdown. Do show running configuration. You can see the IP address allotted to fast Ethernet 0/1 and 0/2. You can also see the IP addresses assigned to interface by giving the command show IP interface brief. It will show only IP version 4 allotted interface, whereas you can see fast Ethernet 0/2, it is showing unassigned. So in order to see IP version 6 address allotted to an interface, you can give the command show IP version 6 interface brief. In show running configuration, you can see both the IP addresses. Now we are giving no SDM preferred dual IP version 4 and IP version 6 routing. We need to reload. Now the default desktop template is in effect. So now it will not show IP address version 6 assigned to fast Ethernet 0/2. Managing the MAC address table. Each network card has a unique identifier called Media Access Control Address. MAC addresses are used in local area networks for communication between devices on the same network segment. Devices that want to communicate with other devices should know the MAC address of other devices before sending out the packets. Switches also use MAC address to make accurate forwarding and filtering decision. When the switch receives a frame, it associates the media access control address of the sending device with the interface on which it was received. The table that stores such entries or associations is known as MAC address table. This table is stored in a volatile memory, so associations or entries will be erased after the switch is restarted or expires after a default timing of 300 seconds. You can also make an entry of MAC address manually into the table. These static entries are retained even after the switch is restarted. So how switches populate the MAC addresses of connected devices like PCs? When switch is first powered on, the MAC address table will be empty. But when host A sends a frame to host B through switch, the switch will add the host A MAC address along with the VLAN and the switch interface associated with host A. The switch floods the frame to all other connected devices because it will not be knowing to which port the frame is destined for. All other hosts except host B will deny the frame as the frame is not destined for them. When host B responds to host A, the switch will learn host B's MAC address along with the VLAN and the switch interface associated with the host B. This is known as dynamic MAC learning. The same is demonstrated here, wherein host A is sending a frame to host B through switch. Initially, the MAC address table of switch will be empty. Now the switch is populating MAC address of host A along with VLAN and the port on which the frame was received. Now the switch will broadcast the frame to all the connected devices except the source port. Host C will deny the frame, wherein host B will respond to the frame. Now the switch will populate MAC address of host B. So this will be, the frame will be forwarded to host A. This is dynamic MAC learning. At the end of the slide, I'm going to demonstrate how the switch will populate the MAC address table dynamically and how to configure the MAC address of each and every host statically in Packet Tracer. Okay. What is static MAC address learning? Normally, your switch will automatically or dynamically learn MAC address and fill its MAC address table by looking at the source MAC address of incoming frames and flooding frames if it doesn't know where to forward the frame. It ages out after 300 seconds and it has to communicate with all the devices connected in order to populate the MAC address table. This process is vulnerable to layer 2 MAC address spoofing attacks, where an attacker spoofs a certain MAC address to change entries in the MAC address table. A real simple method to deal with this issue is to manually configure the entries in MAC address table, and note that static entry will always overrule dynamic entries. You can either specify the interface where the MAC address is located or tell the switch to drop the traffic. If you statically or manually configure the MAC address of the host in the switch, the aging time will not affect and the situations like MAC address spoofing can be avoided. By default, MAC address learning is enabled on all interfaces and VLANs on the switches. You can control MAC address learning on the interface or VLAN to manage the available MAC address table space by controlling which interface or VLANs can learn MAC address. It should be noted, before you disable MAC address learning, be sure that you are familiar with the network topology and the router system configuration. Disabling MAC address learning on an interface or VLAN could cause flooding in the network because LAN switches use forwarding tables or CAM tables to direct traffic to specific ports based on the VLAN number and the destination MAC address of the frame. When there is no entry corresponding to the frame's destination MAC address in the incoming VLAN, the unicast or the frame will be sent to all the forwarding ports within the respective VLAN, which causes flooding. The very cause of flooding is that destination MAC address of the packet is not in L2 forwarding table of the switch. In this case, the packet will be flooded out of all forwarding ports in its VLAN except the port it was received on. This large amount of flooded traffic might saturate low bandwidth links, causing network performance issues or complete connectivity outage to devices connected across such low bandwidth links. So how to disable the MAC address learning on an interface or on a specified VLAN or VLANs? No MAC address table learning, and you can choose one among the options provided: VLAN, VLAN ID or range of VLANs, or on an interface. So you should copy the running configuration to startup configuration. You can specify a single VLAN ID or range of VLAN IDs separated by hyphen or comma. That is, no MAC address learning, VLAN range 1 to 10, comma 15. So valid VLAN IDs will be from 1 to 4094. It cannot be applied on internal VLANs. Command to see MAC address table, show MAC address table, simple. Command to statically configure MAC address, which I will going to demonstrate. MAC address table, static, and the MAC address of the PC or the devices connected, and the VLAN, you can specify VLAN 1 or any VLAN interface to which the device is connected. So to delete statically configured MAC address, no MAC address table, just prefix no. So these are all some show commands. This video demonstrates how a switch will populate its MAC address table dynamically and how to make a static entry of MAC address in MAC table. Remember that static entries will be retained even after the switch is restarted and it is not affected by aging time, that is 300 seconds. I'm using 3 PCs and 1 layer 2 switch, and I will connect these PCs to layer 2 switch through straight through cable. PC1 will be connected to FA0/1 of switch, PC2 to FA0/2, PC3 to FA0/3. So initially the MAC address table of the switch will be empty. So let us verify. We will go to privilege mode and give the command show MAC address table. Okay, the table is empty. Now what I am going to do is assign IP address only to PC1 and PC2 so that this part will explain a dynamic MAC learning, and PC3's MAC address will be statically configured. I'm copying the MAC address of PC1 just for our reference, and I'm going to assign class A IP address. Okay, let me paste it. This is MAC address of PC1. So here all the hosts have to be assigned with IP address in the same subnet and in the same VLAN. Else I have to use layer 3 switch or router to ping the devices. So PC2 is assigned with the IP address 110.1.1.3. Okay, this is the MAC address of PC2. So PC3 MAC address. I'm not going to assign any IP address here. Okay, let's go to simulation mode in order to see how dynamic MAC address learning will happen. The table is empty. Now we will go to a simulation mode. Let me choose only ARP and ICMP protocols. And I will add a simple PDU between PC1 and PC2. Okay. Now PC1 will send the frame to the switch. The switch will not know where to send the packet, send the frame, so it will just forward it to all the ports. PC3 will deny the frame, whereas PC2 will respond to it. Okay, the frame is received. Now let's check the MAC address table. Show MAC address table. See, the MAC addresses are populated dynamically along with the VLAN and the ports. Now I will show you how to statically or manually make an entry of MAC address in the table, MAC address in MAC table. Okay, I will copy this MAC address of PC3. So the command will be MAC address table static MAC address of the PC and the VLAN associated to it and fast Ethernet 0/3. Now I will write the configuration and reload the switch. Let's see whether dynamic entries will be retained or not. Now the switch is restarting. Enable show MAC address table. Only static entry will be retained. Oh, see. Once again we will try, we will reload. Static entry is retained whereas dynamic entries are deleted. Now let me ping PC1 and PC2 so that the switch will populate its MAC address table once again. Now you can see dynamic entries. See. Now we'll write the configuration and again restart it. Now if you want to delete the static entry, just prefix no before the command. The static entry will be deleted. Now we will see. Only static entry is retained. Troubleshoot error disable recovery. Why do some of the switch interfaces or ports goes to error disable mode? There are various reasons for an interface to go into error disable mode. The reasons can be duplicate mismatch. A duplicate mismatch is a condition where two connected devices operate in different duplicate modes. That is, one device operates in half duplicate mode while the other operates in full duplicate. The effect of this duplicate mismatch is the link operates inefficiently. Port channel misconfiguration. An ether channel misconfiguration results in spanning tree loop, which causes the port status to become error disable. BPDU guard violation. Unidirectional link detection condition. The goal of this protocol is to detect a broken bidirectional link. Late collision detection. For Ethernet stations, collisions can be detected up to 51.2 microseconds after the transmission begins, or in other words, up to the 512th bit of the frame. When a collision is detected by a station after it has sent the 512th bit of the frame, it is counted as late collision. Link flap detection. Link flap is a condition where a communication link alternates between up and down states. Security violation. Port aggregation protocol flap. Incorrect GBIC or SFP module or cable. Inline power misconfiguration. Suppose an interface gigabit Ethernet 1/0/1 has been configured for power on Ethernet auto mode with a maximum power of 6 watts. Unfortunately, the connected devices would like to use 15.4 watt. As a result, the switch rejects the power request and keeps the device in a not connected state. What is error disable state?
Error disabled is a feature on Cisco switches which automatically disables an interface on certain conditions. By default, ports put into error disable state must be re-enabled manually. This is done by issuing the shutdown command in the interface configuration mode followed by no shutdown command. If any error disable causes are configured for automatic recovery, the error disabled port stays for 300 seconds, that is 5 minutes by default. You can set the interval for from 30 to 86,400 seconds. So how this can be done? By giving the command error disable recovery interval. You can give the timings here. You can specify the timings here in seconds. You can determine if your port has been error disabled if you issue the show interface command. Suppose you have given show interface fast ethernet 0/1. It shows fast ethernet 0/1 is up and line protocol is up. The first up tells the state of the port's physical layer. The link is physically connected or not. The second state given as line protocol up shows the layer 2 status. Some of the commands you can practice in the lab: show port security interface fast ethernet 0/1, show port security address. If you have enabled error disable recovery, you can determine the reason for the error disable status if you give the command show error disable recovery. Error disable recovery cause all. This command brings back the interface to working mode by enabling the timer to recover interfaces from all the causes. Error disable recovery cause all or BPDU guard. You can select any of the options here. So to revert to the defaults, use the no form command of this. No error disable recovery cause all. This video demonstrates how an interface of a switch gets into error disable state. I'm taking port security violation scenario as an example, wherein a switch interface is configured to learn a maximum of one MAC address goes into error disable state when it detects a second MAC address on it. We'll go to privilege mode and check for MAC address table. The table should be empty. Now we will configure port security on fast Ethernet 0/0 interface, 0/1 interface. Switch port security. Okay, this is a dynamic port. Port security can be enabled on both access as well as trunk ports, but we cannot configure port security on a dynamic interface. For this, you need to make this port as an access port by giving the command switch port mode access. Now it has taken. Switch port security maximum is to set the maximum number of secured MAC address on a port. Here you can set up to 132 MAC address, but I will set it to 1. Switch port security MAC address. If you give question mark, you get the options. You can either manually configure the MAC address if you know the MAC address of connected device, or just simply give sticky. Switch port security violation has got 3 options: protect, restrict, and shutdown. I will choose shutdown. Enable this port and check for the MAC address table. I will assign IP address to this PC and try to send frames to the switch. In the meantime, let me explain what is this protect mode, restrict mode, and shutdown mode. This protect mode works only in sticky option. This mode will just drop the frames coming from a non-allowed MAC address but keeps the port operational. In restrict mode, frames from non-allowed MAC address would be dropped and an SNMP trap will be sent. Shutdown mode will simply shut down the interface and sends an SNMP trap. Now the MAC address is populated. So this is the MAC address of PC0. Now what I will do is I will just remove this PC and I will connect one more PC. Since the maximum number of MAC addresses is set to 1, the second MAC address is not allowed, and the fast Ethernet 0/1 interface should go down as soon as it receives frames from PC1. It still shows PC0's MAC address. I will assign IP address and try to ping so that frames can reach fast Ethernet 0/1. Let me assign the IP 10.1.1.2. Now the port should go down. Yes. The port has gone down. Show interface fast Ethernet 0/1. Now you can see the port has gone down, or it has gone to error disable mode. If you want to enable that port, you have to manually give no shutdown and no shutdown command. Now if you give show MAC address table, it still shows PC0's MAC ID. You can cross verify here. If you give show running configuration, you can see all the configuration details here. Show port security address. This shows maximum address limit as this system can learn, this switch can learn. Show interface, show port security interface, fast Ethernet 0/1. You can see maximum MAC address that can be learned is set to 1. These commands you need to practice. Now the interface has come up. To revert it back, you can use no form of these commands.